2 3s are 0. 2 4s are 8 means 2. 2 5s are 10 means 4 back. Now you can see 3 1s are 3. 3 2s are 0. 3 3s are 3. 3 4s are 0. 3 5s are 3. 4 1s are 4. 4 2s are 2. 4 3s are 0. 4 4s are 4. 4 5s are 2. Go for 5. 5 1s are 5. 5 2s are 4. 5 3s are 3. 5 4s are 2. And 5 5s are 1. I suppose you are familiar with this kind of table in Z6. Many a times we have drawn this. Any doubt regarding the table? Okay. Now here you can watch that the product becomes 0 here. Product of 2 with 3. We got this to be 0. 3 with 2 and 3 4s is also 0. Then you have 4 3s are 0. So this many answers you got 0. What are the 0 divisors? 2 is a divisor of 0. 3 is a divisor of 0. 4 is a divisor of 0. I feel all of you are getting. And what you observe, 2 and 6, what is their GCD? 2. GCD of 3 and 6, 3. GCD of 4 and 6, 2. So they are, yes, they are not relatively prime. But you can see 1 and 6 are relatively prime, 5 and 6 are relatively prime. So 1 is not a divisor of 0. 5 is not a divisor of 0. I feel all of you are following this. Okay. So what you observe, whenever a number, an element is relatively prime to n, it is not 0 divisor. Remaining all are 0 divisors. So in the ring Zn, the divisors of 0 are precisely those non-zero elements that are not relatively prime to n. This we observed from this table. What are the 0 divisors? 2 is there, 3 is there, 4 is there, but 5 is not. 5 is not a 0 divisor. 1 is not a 0 divisor. So the numbers which are relatively prime to 6, they are not divisors of 0. This we mean. Have to prove it. So you can see the proof. You take an element m from Zn. M is non-zero very specifically. And the GCD of m and n we are taking to be d. GCD of m and n is d means what? The greatest common divisor of m and n is d. So m is equal to suppose a dx and n is dy. Then x and y will not have any common factor. This is what we mean. The greatest common factor is d. All right. So what is going to happen? So m times n upon d. M times n upon d. So in this case, you can see m into n upon d is y. M times n upon d is y. And if you take x, so very directly what you can see, this is nothing but d into x into y. Is it so? M is dx into y. So can I take this x aside and multiply dy? So what I got? X into n. This is what we mean by this statement. M upon D means X. N upon D means Y. So what we got? M into Y is nothing but X into N. Now, M upon D into N gives 0 as a multiple of N. Because what you are saying, divisible by N. It's a product N. Means in Zn, this value is equally 0. As in case of this 2 3s, if I take, I got 6. But 6 I replace as what? 0. Thus you got this M into Y to be multiple of N. So you can replace it as 0. So what you have shown? M is a divisor of 0. Same way. So we were talking about element M. As you talked in case of 2 3s are 0. Same way you got M into something, M into Y at 0. So M is a divisor of 0 apart from being non-zero number. I would like to repeat this once again. I chose one element from Zn. Now, what was the relation of M with N? So the GCD was not 1. If GCD is not 1, I would like to go with the factorization. How we talk about the GCD? The greatest common factor into uncommon factor. That is what I have written. Now I start with M into uncommon factor Y here. This is nothing but dx into y. D and y, if I combine, I get n into x. So this m into y becomes multiple of n. This we wanted to show. And if it happens so, the answer is 0 because it is a remainder when divided by n, it's 0. So m is a divisor of 0. So what you have shown? M is a divisor of 0 when GCD of M and N is not 1. Now, reverse way. If we say M is relatively prime to N, then what will? Because we want precisely those elements. So those which are not relatively prime, what happens with them? If those which are not relatively prime, they are 0 divisors. Now, if suppose M happens to be relatively prime to N, then GCD of M and N is 1. See, if for S belonging to Zn, we have M into S is equal to 0, then N divides the product M into S. Now, N is relatively prime to M means N will not divide M. So, N has to divide S. But what is S in Zn? S is 0. So, that is the only case when it will become 0. That is the only case. So, you can watch over here. When I multiply it to 0, in that case only it will be 0. So this row was important for us. See, 0 into 1, 0, 0 into 2, 0, 0 into 3, 0, 0 into 4, 0, 0 into 5, 0. So in case of 5, if I multiply it to 0, then only the answer will be 0. Otherwise the answer cannot be 0. Here also you can watch 0, 0, 0, 0, 0 and a 0. So 0 into 5 is 0. Nothing else is 0 here. So whenever my element is relatively prime to n, the answer will be 0 only if I multiply to 0. Otherwise it cannot be 0. Followed the proof? Okay. I would like to expand it for you and I'll present it to you. Okay. And bit ahead I would like to go. What will happen if I talk about Z3? If I deal with Z3, what are the divisors of 0 here in Z3? There are no zero divisors because if P is prime, every number is relatively prime to P. Obviously, there are no zero divisors. Okay. I suppose you got me. If I deal with Z7, you find out the table of Z7, multiplicative table. You'll find in no column you get 0, except for you multiply to 0. So in ZP, there is no zero divisor provided P is a prime. So with this, I would like to stop for today. Bye then.
Hello, ma'am.
Wait a minute. Wait a minute.